You ever use an app and it just feels smart? Like it always has the perfect answer right when you need it? Well, the secret isn't that it has one single giant brain. The real trick is that it might have many brains, all working together across different clouds. Today, we're going to pull back the curtain and see exactly how to build a powerful cross-cloud AI brain. So picture this. Your app needs an answer, and it needs it now. Who should it ask? Should it turn to Amazon or Microsoft or Google? It's kind of like when you need to buy something. Do you go to the store that's closest, the one that's cheapest, or the one that has the absolute best quality? Your app is making that exact same choice, but it has to do it in milliseconds, over and over again. And this leads us right to what's called the multi-cloud promise. It's this really exciting idea that you don't have to pick just one. You can get the best of all worlds. You can use the coolest AI tool from this provider and the cheapest one from that provider. But, when something sounds that good, there's usually a catch. And here it is. It's that classic trade-off, right? On one hand, you have the simplicity of just sticking with a single cloud provider. It's easy, but you're kind of locked in. On the other hand, you have the incredible power of a multi-cloud setup. But with all that power comes a whole lot of complexity. So the big question is, how do you manage all that complexity without losing your mind? So yeah, that's the real challenge. We need to build a system that can act like an incredibly smart traffic cop for all our AI requests. Something that can, in an instant, figure out the absolute best place to send each and every request. And that brings us to the hero of our story today, the smart router. Think of it as that brilliant traffic cop. It sits right in the middle of everything, looking at all the incoming requests from your app and the whole universe of AI models out there, and it just directs traffic perfectly. Okay, before we see this router in action, we gotta quickly cover a key term: inference. I know, it sounds super technical, but it's really simple. Inference is just the fancy word for the moment you actually ask an AI to do something. You show it a picture and ask, what's in this? That whole process of the AI looking, thinking, and giving you an answer? That's inference. So how does this smart router actually work its magic? Well, it's like a quick 5-step dance that happens in the blink of an eye. A request comes in from a user, the smart router immediately intercepts it. Then it quickly looks at all its options. It's checking for speed, for cost, for the model version all at once. It picks the best one, in this case, let's say it's Google, sends the request on its way, and then the answer comes right back to the user. And the user has no idea all that complex choreography just happened behind the scenes. All right, now that we get the basic flow, let's dig into the router's superpowers. And first up is its absolute obsession with speed. This is what we call the latency-aware approach, and it's all about one thing: getting you an answer as fast as humanly, or, well, digitally possible. And the logic here is actually super simple, but it's so powerful. The fastest AI is the one that's physically closest to your user. I mean, think about it. You wouldn't order a pizza from a place 3 states away, right? Of course not. It would take forever to get to you. The exact same idea applies to data. Our smart router is always looking for the local pizza joint to cut down on travel time. And just look at this. In this scenario, for this particular user, Google Cloud responds in just 40 milliseconds. In that same amount of time, Azure is still just getting started. This is the kind of split-second intelligent choice our smart router makes every single time, making sure your app feels incredibly snappy. But look, speed isn't everything. Sometimes you might be totally fine with waiting an extra few milliseconds if it means saving some serious cash. And that brings us to the smart router's next superpower: cost optimization. You can think of the smart router as your own personal, tireless bargain hunter for AI. It is constantly scanning the prices across all the providers. So here, for an image recognition task, it sees that Google Cloud is way cheaper than Amazon. We're talking 30% cheaper. Now, for one request, that's not much. But multiply that by millions or even billions of requests. Now you're talking about real money being saved. So our router can make things faster, it can make them cheaper, but what about making them better? How does it help you innovate and roll out new, smarter AI models without, breaking everything? Well, that's its final superpower: agility. This is a question that keeps engineers up at night. You've spent months building an amazing new AI model. It's smarter, it's better, you think. But what if you're wrong? What if there's a bug? You can't just flip a switch and push it out to all your users. The risk is just way too high. The solution is an incredibly clever technique called a canary release. You know, like the canaries that miners used to take into coal mines to get an early warning if there was any danger? It's the same idea. The smart router lets you send just a tiny, tiny fraction of your user traffic to the new model. It's like a little test run in the real world. So you can see here, 95% of your users are still using the old, stable, trusted model. They notice absolutely nothing. But that other 5%? They become your canaries. You get to see how the new model performs with real users and real data, all in a super safe, controlled way. It's an amazing way to innovate without the fear. So when you put all of these pieces together, the routing for speed, the routing for cost savings, and this incredible agility to test new things safely, what do you actually end up with? Well, you get something much more than just a router. You get a truly future-proof AI brain. Let's just quickly recap the benefits because they're huge. Your system is more resilient because if one cloud provider has an issue, you just route around it. It's way more cost-effective because you're always shopping for the best price. It's more powerful since you can use the best AI for each specific job. And maybe most importantly, it's future-proof. A new amazing AI model comes out tomorrow, no problem. You can plug it right in. So I'll just leave you with this final thought. The whole reason the internet works, the reason it's so robust, is because no single company owns it. It's a decentralized web. As we move deeper into this new age of AI, maybe we should be asking ourselves the same question. Should we really let one single company own the brain of our applications? Or should we build something better?